Hey guys, Mrs. Homan here with another science video. Today we will be discussing the properties of stars. So let's get started with a little review. Let's remember from the previous video on galaxies that a star is a large celestial body composed of gas and dust and emits energy in the form of light and heat. Let's also recall from our unit on energy that stars get their energy from nuclear fusion, fusing two hydrogen atoms into one helium atom. In the star's core, this converts matter, the atoms, into energy, light, and heat, which is where Einstein's E equals mc squared equation comes from. Energy is equal to mass times the speed of light squared. We can look into the sky during the day or night and notice that there are differences among the stars. There are 4 ways that we will be discussing that stars can differ: composition, size, brightness, and color and temperature. First, stars can vary in their composition or what they're made of. Stars are primarily made of hydrogen, about 71% hydrogen, 27% helium, and 2% other elements, such as oxygen, carbon, neon, iron, and others. You may be wondering how we could know this if we can't take samples of stars. Well, a spectrograph allows us to determine the elements found in stars by determining which wavelengths of light are absorbed by the star. Here is a picture of a spectrograph. The black lines in the visual or the dips in the graphical are where light is being absorbed. These are then compared to spectrographs of known elements, and if the absorptions match, then that element can be found in that star. Next, stars can vary in size. Stars are measured by comparing their radius to the sun. The sun's radius is about 695,000 kilometers. Giants and supergiants are greater than 10 times the size of the sun. Main sequence stars are around the size of the sun, between 10 and 0.01 solar radii, and the smallest stars are white dwarfs and neutron stars, which are less than 0.01 solar radii. Next, let's talk brightness. Some stars appear brighter than others in the night sky. However, one may appear brighter simply because it's closer to Earth. Absolute magnitude or luminosity is a measure of how bright a star would be if it was located at a standard distance, or its actual brightness. Apparent magnitude is a measure of a star's brightness as seen from Earth. This can be affected by both its absolute magnitude and its distance from Earth. I have my favorite graphic below to explain this. If both person A and B have the same flashlight, their absolute magnitude is equal. The actual brightness of the flashlight is equal. However, from the perspective of the tent, person B's flashlight has a higher apparent magnitude because he's closer to the tent, not because his flashlight is brighter than person A's. The sun is the star with the greatest apparent magnitude in our sky. While it has an average absolute magnitude, it is so much closer to Earth than any other star, it appears the brightest. The last way stars can differ is their color and temperature. Now you may be thinking, hold on, Mrs. Homan, that's 2 ways. Why are you listing it as 1? Well, stars are black bodies. A black body is an object whose color depends only on its temperature. Stars vary in the color they appear in the sky, and this color reflects their surface temperature. The highest temperature stars are blue, then white, yellow, orange, and the lowest temperature stars are red. A Hertzsprung-Russell or HR diagram plots stars by their temperature on the x-axis and their absolute magnitude or luminosity on the y-axis. The hottest, brightest stars are found in the upper left corner of the diagram, and the coolest, dimmest stars are found in the lower right corner. As you may notice by looking at the diagram, the temperature is connected to not only the color of the star, but also its absolute magnitude. And we can see that as surface temperatures increase, so does absolute magnitude. Scientists use the HR diagram to understand how stars change over time. During its lifetime, a star will evolve on the HR diagram, moving on the diagram as it moves through its life cycle. You can see along the diagonal are main sequence stars like the Sun. Along the top are supergiants like Betelgeuse. In the middle on the right are giants like Pollux. And along the bottom are the white dwarfs like Sirius B. That's it for stars. Thank you so much for watching. Have a marvelous day.